Okay, let's finish this chapter. Colgatinotap says, do you understand fmap already? Understand is a strong word, Colgatinotap. We did check through the fmap, right? It's just, right, you map a function to something that is a container, right? You map your function to everything in your container. A container, usually we think of them as lists, right? That's why when we do map, we do it on every item in the list. But fmap, you can do it on maybe values, you can do them on trees, on your own data structures, right? And what it does a function on every single item in your container, box, if you will. So, I can kind of explain what fmap is, but understand it fully, I don't know about that. I understand it conceptually, but I haven't practiced implementing it, right? This book is very good at explaining stuff conceptually, but we don't do a lot of practice, like actual functional practice. Sorry, functional practice. Now I'm just throwing words out there. We haven't done a lot of practice within this book, and that's like I guess that's my fault a little bit. And well, doing some more code wars is good for you, yeah. But right now we're learning about type foo, kinds and some type foo. Kinds? This seems like something completely new. Type constructors take other types as parameters to eventually produce concrete types. Yes, you remember that. That kind of reminds me of functions, which will take values as parameters to produce values. That happens, yeah. We've seen that type constructors can be partially applied. Either string is a type that takes one type and produces a concrete type, like either string int. Yeah, exactly. Just like functions can. This is all very interesting indeed. In this section, we'll take a look at formally defining how types are applied to type constructors. Just like we took a look at formally defining how values are applied to functions by using type declarations. You don't really have to read this section to continue on your magical Haskell quest, and if you don't understand it, don't worry about it. However, getting this will give you a very thorough understanding of the type system. Alright, that's a very good thing that they pointed this out, because I already feel a little bit lost, but that doesn't mean that you might not be lost. So we're gonna keep going, yeah. I want to finish the chapter, I don't want to skip it. Even if I don't get it, I don't want to skip it. So feel free to yourself, I guess. So values like 3, yeah, or take while. Functions are also values. Right, I remember that, because we can pass them around and such. Have their own type. Right, but 3 is a concrete type. Yeah is a concrete type. Take while is one of the not concrete type. What did he call those? Constructors. That's a constructor then, right? Yeah. Well, that's very kind, Jabok. Right. Each have their own type. Types are little labels that values carry, so that we can reason about the values. That makes sense, right? Yeah. Little labels on our types. That's what they are. It's like someone asks you who you are, just simply, right? Usually sometimes people respond with, well, I'm this is my name, this is how old I am, this is, right? Some labels. Well, no, what is identity? A lot of, like, if we don't go into the philosophy of identity or whatever, you usually have name, age, gender, so far, right? Little labels that we carry with ourselves so we can reason about it. Sure. But types have their own little labels called kinds. Oh, there's so much meta going on in this book, isn't it? Yeah. Right. A kind is more or less the type of a type. Kind is more or less type of a type. This may sound a little bit weird and confusing, but it's actually a really cool concept. Alright. Thanks again, J-Bok. I'm going to bed now. Good luck with the kata. Oh, now we're reading the book, Learn You a Haskell. Yeah. We might do another kata after this chapter. I don't know. We'll see. I feel like I owe Colgate Tap an extra kata. Yeah, since I just kind of bamboozled. Is that the word? I don't know. Right, but sleep well, J-Bok. What are kinds and what are they good for? Well, let's examine the kind of a type by using the K command in GHCY. Oh, so we can check kinds just like we check T for type, right? Right. We check kind for our int, and int multiplication, the asterisk, star. How quaint. What does that mean? A asterisk, or a star, sorry, a star, he called it a star, means that the type is a concrete type. A concrete type that doesn't take any type parameters and values, can only have types that are concrete types. If I had to read star out loud, I haven't had to do that so far. I'd just say star or just type. I am a little bit confused. Okay, now let's see what the kind of maybe is. Maybe it's a star to a star? It constructs a type. Oh, no, it's a type. It constructs a type from a type. An int is just a type. Colgate Tap says, we're dealing with stars now. That's so weird because my mind goes to multiplication when I see this star. Right, the maybe type constructor takes one concrete type. Okay. Oh, right. The star is a concrete type, like int, and then returns a concrete type like maybe int to different concrete types. And that's what this kind tells us. Just like int to int, yeah, means that a function takes an int and returns an int. That way a constructor takes a type and takes a concrete type and returns a concrete type. Means that the type constructor takes a concrete type and exactly, yeah. Let's apply the type parameter to maybe and see what kind of type it is. Right. A maybe int. Maybe int is just a concrete type. Okay. Just like I expected, we applied the type parameter to maybe and got back a concrete type. That's what the star to star means, that we, take a concrete type and we return a concrete type. A parallel, although not equivalent, types and kinds are two different things. It's if we do T is upper and T is upper A, the parallel, not equivalent, but I'm kind of happy with the parallel because it looks exactly the same. it's just about types, it's not about functions. Wait. No, it's about... What is this again? What are we talking about? Kinds. Here we go. Types and kinds. Oh man, these words, so vague. Wait. Equivalent, yeah, type bool, because its value is basically true. Both of these types, however, have a kind of... Its kind is a type. Oh man. Yeah, we're doing meta stuff now. We use kind, the :k on a type to get its kind, just like we use :t to get a value to get its type. Like we said, types are the labels of values and kinds are the labels of types. And there are parallels between the two. I'm quite happy with the parallels, yeah. It probably might be a little bit confusing when we look into this. Untitled is reading the A arrow B arrow C, this kind of notation. What are you saying, Colgating? It's easier now. You used to dislike it, if I recall correctly. I did dislike it in the beginning because I had no idea what was going on, right? I don't think I disliked the syntax of doing things this way. It was just confusing. And you know me, when I feel confused, my ego flare up and I feel all frustrated, disliking what's going on. So yeah. But yeah, of course it's way easier now. I think that even the curried function chapter, I think that is when this really clicked, when we read about curried functions. And it's becoming way easier every time we read it, isn't it? And the easiest way is just to say, right, it makes sense, right? We return something and we take everything that's in front. It's still... it's okay. It's okay for now. Let's look at another kind, which is the kind of either. Either will take, right, a concrete type and another concrete type, and it will return a concrete type. Right. And the either returns its own specific type, right? Its specific concrete type, just like maybe returns its concrete... Maybe returns, oh sorry, a just or a nothing, right? Either did the same. Not the same, but something similar. Aha, this tells us that either takes two concrete types as type parameters and produces a concrete type. Yep. It also looks like, kind of looks like a type declaration of a function that takes two values and returns something. Yep. Type constructors are curried, just like functions, so we can partially apply them. Alright, so the k either string, alright, concrete type, concrete type, and either string int. Oh, right. We're just looking at either. We're not looking at what the type is, because the type is... it's just a concrete type. We're not looking for types because we're using the k, not the t, so it's not relevant here. Yeah, when we wanted to make either a part of the functor type class, we had to partially apply it because functor wants types that take only one parameter while either takes two. In other words, functor wants types of kind, concrete type to a concrete type. And so we had to partially apply either to get this kind instead of the original, where we took two different concrete types to return or yeah, our new concrete type. There we go. If we look at the definition of functor again, right, that's a class. Functor f, where fmap take a function that takes an a to a b, and then we apply it to the, this confuses me though, right? This is our function, right? And we apply that to a and b. All right, we see that the f type variable is used as a type that takes one concrete type to produce a concrete type. Right, we know it has... Colgate says it was kind of the author to... Oh man, you're messing with me now, aren't you, Colgate? It was kind of the author to tell... to not understanding this section is kind of fine. Yeah, it was kind. Very kind. Yep. What is happening? Right. We know it has to produce a concrete type because it is used as the type of a value in a function. I feel like I'm saying the words, but I'm not hearing them. And from that we can deduce that the type that want to be friends with functor has to be of the kind where we take a concrete value to another concrete value. That because of the a's and the b's? Now let's do some type foo. Take a look at this type class that I'm just going to make up right now. Class tofu. Nice. I like tofu. Sometimes. It can be very bland. Right. We have a class tofu t where tofu takes j a t a j. What does the j represent? Man, that looks weird. Yeah. How would we make a type that would be an instance of that strange type class? Well, let's look at what its kind would have to be, because JA is used as the type of a value that the tofu function takes as its parameter. JA has to have a kind of a concrete type. And this has to be a concrete type, just like this has to be a concrete type. Right, that actually... This has to be a concrete type, this has to be a concrete type, and this has to be a concrete type. Is that what we're saying here? Yeah, because a function, this is how we do a function within a function, right? Fmap takes a function, and this is a function, but this function returns a concrete type. Thinking that is how it works, yeah. Right. A has to have the type of a concrete type. We assume a star for A so that we can infer that J has to have a kind of concrete type into a concrete type. Do we have to assume that? Isn't that just how the syntax works? That the J has to be the function, right? Colgatino tab says maths? Wait, did we do maths? No, run away. Right. We see that T has to produce a concrete value 2, and it takes 2 types. Wait, how can J... Yeah, that becomes confusing then, doesn't it? Wait. And knowing that A has the kind of concrete type and J has the kind of a type into type, we infer that T has to have a kind of concrete type that creates a function that creates a... Wait, is this... Shit. We infer that T... Oh, right. T has to take this. That's our A. And then we have to take that, which is our J. And of course we have to return a concrete type because that's what we have to do. So this whole thing returns a concrete type. Right, so it takes a concrete type A and a type constructor. That's what it is, yeah. The J is a type constructor. Yeah. Shit, I forget that name, constructor, all the time. Which is weird, because it's a pretty good name. That take one concrete type J and produces a concrete type. Wow. Oh, right. Wait, so T, that's our... Right. T is our function that we apply to it. Man, this is confusing to unpack, yeah. Right, A could be star to star, yeah. That's... And J has to be... Yeah. That's A into this, and this is J into that. Yeah. Man. Okay, so let's make a type with the kind of this. Alright. Here's one way of going about it. Right, we create our data type, Frank, AB, which is Frank field, BA, deriving show. Okay, Frank. This is a constructor of some sort, right? Where Frank is Frank field, a driving show. Oh shit, I don't remember this. This was a long time ago. All right, how do we know this type has kind of this? Well, fields in ADTs are made to hold values, so they must be kind of type. Yeah, A and B are values. Obviously, we assume a concrete type for A, which means B takes one parameter as its kind, so it's a concrete type into a concrete type, right? B into A. Now we know the kinds of both A and B, and because they're parameters for Frank, we see that Frank has a kind of this. The first star represents A, and the two stars within the parentheses represents B. Let's make some Frank values and check out their types. Oof. Record syntax. Oh man. I remember seeing that record syntax, but it doesn't compute exactly what we were talking about. Right, let's see if we can figure it out. Right. Frank field is just... Haha. Here we go. That's our... Yeah. Right, so Frank is Frank field just... Oh, right, our type is Frank and then a string and... Wait, why does the maybe end up here? Yeah, that confused me. The maybe. Alright, the type of Frank. Oh, right, we implement our Frank field. Node A empty tree, which returns a character tree. Oh man. Because Frank field has a type of the form AB, its values must have the types that are of a similar form as well. So they can be just haha, which has a type of maybe string, or it can have the values of these characters, a list of characters, which has the type of string as well. Wait, how would you do this? We'll get in on tab says maybe, because maybe is this in this whole thing. Yeah. What confused me is not that the maybe exists here, right? That makes sense to me. What confused me is that it says that maybe ends up after string, right? Because we says just haha, but we say string maybe. Shouldn't it be Frank maybe string instead of Frank string maybe? That is what threw me off. That I didn't get, and the ordering of this, I don't know if I want to understand it. It just confused me more. That thing. It feels like it's not really relevant for this part of the chapter. Here we go. Type maybe string, but here it says string maybe. Right, which is a type of list of characters. If we used our own list type for this, it would have been a list error, right? And we see the types of the Frank values correspond with the kind for Frank. Okay. Right, I'm sure you understand what's going on, Colgate on tab. Yeah, he shows that this structure would have been different, but it's kind of a mess. Yeah. Right. String has a kind of concrete type, and maybe has a kind of take an asterisk into an asterisk, because in order to have the value, it has to be a concrete type, and thus it has to be fully applied. Every value of Frank blah 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 has kind of a concrete type. Making Frank an instance of tofu is pretty simple. We see that tofu takes JA, so an example type of that form could be maybe int and return EAJ. So if we replace Frank with J, in the result would be the result type would be Frank int maybe. Alright. Not very useful, but we did flex our muscles. Yeah, you did flex your muscles, indeed. Just flexing, yeah, this feels like flexing. Let's just do some more type foo. We have this data type. Oh man, it's getting even worse, isn't it? Data Barry TKP Barry Yabba Dabba no do. Now we want to make an instance of functor. Man, it's getting worse. Oh man, it's getting worse. Yeah, you lost me over here. Yeah. Somewhere along here, I'm lost. I'm not here anymore. I'm just gonna read and let you do you, yeah. Alright. And now we see we want to make an instance of functor. Functor wants types of kind concrete type to a concrete type, but Barry doesn't look like it has that kind. What is the kind of Barry? Well, we'll see that it takes 3 type parameters, so it's going to be something, something, something into a concrete type. That makes sense to me, yeah. It is safe to say that P is a concrete type, and thus it has the kind of a concrete type, because it's the last one. For K, we assume concrete type, so by extent, wait, why do we assume that K is a concrete type? T has the kind of a concrete type into a concrete type. Right, let's just replace those kinds with the somethings that we used as placeholders, and we will see that it has the kind of boom. Right, let's check that with GHCI. Hey, Barry. Yeah, this assumption I don't get. Ah, we were right. How satisfying. Now, to make this type of functor, we have to partially apply the first two type parameters so that we're left with a concrete type into a concrete type. That means that the start of the instance declaration will be instance functor Barry AB, where if we look at fmap as it was made specifically for Barry, it would have a fmap take a function into a Barry CDA into a Barry CDB. All right, because we're mapping our A to B. Exactly. Because we just replaced the functors F with Barry CD. Yeah, okay. The third type parameter from Barry will have to change, and we see that it's conveniently in its own field. There we go. We've just mapped the F over the first field. Sure, I'll take your word for it. In this section, we took a good look at how type parameters work and kind of formalized them with kinds. Are you? Right, kind of formalized them. Yeah, sure. Just like we formalized function parameters with type declarations. We saw that there are interesting parallels between functions and type constructors. They are, however, two completely different things. When working on real Haskell, you usually won't have to mess with kinds and do kind inference by hand like we did now. Usually, you just have to partially apply your own type to a concrete type into a concrete type, or just a concrete type when making it an instance of one of the standard type classes. But it's good to know how and why that actually works. It is also interesting to see that types have little types of their own. Again, you don't really have to understand everything we did here to read on, but if you understand how this works, chances are that you have a very solid grasp of Haskell's type systems. I do not. I gotta say, I feel that this entire chapter is in the wrong spot. Yeah. Let's go to our table of contents here and we check. Introduction was fine, starting out was fine, type in type classes, syntax in functions. Yeah, that was fine. Recursion was fine, higher order functions. Modules. This chapter did not fit into what I needed. Yeah. I feel like input-output would have become way earlier. Functionally solving problems, yeah, this is way should have come first. Functors, here we go. I feel like chapter 8 should have been put in here before this functor thing. After functionally solving problems. Yeah. This whole... Maybe even a lot of this chapter should have been taken out and put in as extra information in other chapters. I don't know. I did not like this chapter. Overall, feel more confused now. Maybe. Colgatinotap says, you made it to the part where you are ready to learn Hello World. Well done. Nice. We've made it to input and output. Right. Let's read the introduction to input and output at least, right? We've mentioned that well, actually... No. I feel like I owe Colgate InnoTap another kata in Code Wars, so we will start with input and output another day and finish off the day with just making another kata here. Expressions matter, is that what we're doing? Let's see if we can finish this one. I have had a little bit of bad luck, I don't know. With these, let's see here. What are we doing? Expressions matter. Don't know what this is. Right. Our task is that we're given 3 integers, a, b, and c, and we return the largest number obtained after inserting the following operators and brackets. Plus, multiply, and parentheses. Wait, in other words, try every combination of a, b, c with these operators and return the maximum obtained. It seems like we're doing maths, but this solution does not have a math solution, right? This should have a Haskell solution, right? Colgate InnoTap says bookmark this where you have filtered katas by tag. No, I think there were a couple of other tags that I was curious about Colgate InnoTap. So I'm thinking that I can pick one of the tags that I'm interested in just randomly. I did that first, yeah, this morning I went in, did that with the bookmarks. Oh, hello, Old Drop, nice to meet you. Name for some reason, Old Drop. This browser looks cool. Which one is it? This is the cute browser, yeah. It is, we're trying to do Vim stuff, if you know Vim. Cute browser, yeah, exactly. Good looking out. It is spelt like Colgate InnoTap just typed out. Cute browser. It has Vim bindings, so you can use the most of it with the keyboard. You don't have to use the mouse. It's not really designed with the mouse in mind, but it works. Right, my favorite part of this, I'm gonna show my favorite part of this browser while we're doing this, is we search for, we can search for cute browser. And if we go in here and we press F, boom, see those yellow little dots showing up? If I now press LG, we follow the link. That's one of my favorite features. We go back and forward, we can do everything with the keyboards. And we just like Vim, if we press colon, we get a little thing here where we get a lot of commands that we can do everything with the commands, right? Like I just got my new ad block. Old Drop says, yeah, I might try it out. The clicking looks really useful. There are ways to add that to Firefox, I know. What do they call that? Vimperator? You can use add-ons to your Chromiums and your Firefoxes to have this functionality as well. But this browser is built with that philosophy from the ground up, I suppose. Node owner says, what ad block did you use? Alright. This browser unfortunately uses 2 ad blocks. It uses its own host block thing that, I don't know, it has its own host block things, and it's using the Brave browser's own ad blocker, yeah. Colgate InnoTap says that Vimperator broke when Firefox changed everything. What is it called then? Vimium? Is that the one? Sorry, I got sidetracked a little bit. Vimium Firefox. Is that the one then? Maybe Vimium FF for Firefox. Hacker's browser, sure. Maybe it's the Vimium. I think I used Vimium for a while. Yeah, but Vimperator broke, like you said. I think Vimium was the one that I used. Vimperator was really good. I'm pretty sure I used Vimium. Vimium was fine. Yeah, I enjoyed Vimium. Right. Node says tridactyl. Is that another add-on for it? In other words, try every combination of ABC with this and return the maximum obtained. Wow. Alright, with the numbers 1, 2, and 3, here are some ways of placing the signs in brackets. This is gonna take a while, I think. Set this up. Yeah, we have this set up, right? 1 multiplied by 2 plus 3 equal to 5. Oh! Right, you don't have to use all of them. Well, no, you do have to use all of them in all possible combinations. Because you can just do 1 multiplied by 2 multiplied by 3. Wait, isn't that always the biggest one? No, if there's a 1, we want to have plus, right? If there's a 1, we'll do a parentheses and plus it to whatever and multiply. Like, this is the biggest one. And that is always going to be the biggest one. Just like if we have 0, we have to have a plus as well. Because we don't want to multiply with 0, we don't want to multiply with 1. But everything else we want to multiply with, right? Fucking maths. But that's the case, right? If we have a 1 or a 0, we want to plus that with the... Oh, it doesn't matter. We want to plus that with one of the values next to it. It doesn't matter which one, does it? See you. 1 plus 2 would be 3 times 3, right? That would be 9, but 2 times 4 is 8. No. We want to plus the two lowest values together. If there's a 1. Yeah, the smaller value. That's the one we need. Right. Do we code all that out? Right. That is definitely... Right. Expressions. Wait. And we always get 3 integers. Yeah. Expressions. Right. So if we take 1... Wait. We get ABC, right? We got 3 values. And we want to, if... Right, we have a guard where A is equal to 1 and the other ones are... Shit, no. That doesn't work because we want to check all of the values. If any of the values are equal to 1 or 0. How do we do that? Do we put them in a list and just take any one? Right, I don't want to do this, right? This is not how... Oh shit. This is definitely not how to do it. Right? We could do it this way, but this peak coding, that looks awful, doesn't it? I don't really know how to do it a better way, right? Because we have to do, right? Again, we would have to do, oh shit. That's BC, sorry. I mean, we could do it this way. I suppose. But then we would have to put more guards over here, right? We would have to do like a where function. where B is smaller, well, where if B is smaller than C, then otherwise, yeah. Holy shit. That's a lot of work. There has to be a better way to do this. What if we treat this as a list? And we just, we make a list out of A, B, C, and we say if 0 is in list, do this. If A is in list, do that, right? And that's probably easier. This looks fucking awful. I'm gonna keep that there for now, just for visualization, my own sake, because we need to, those are the specific commands, right? Because, right, we would end up with the otherwise we just return A multiplied by B multiplied by C. So we take expressions. Can we do this? No, we can't do that. All right. A, B, C. So what we can do, right, is that we can just make a list of A, B, C, right? And we can do stuff with the list instead. Right? I'm thinking the best way to do it is to get by index, right? Right, we try to get 1 by index. That's, I'm pretty sure that's part of our modules, right? That's our data.list. Or was it part of index? Elem is kind of like the elem, only it doesn't return a Boolean value, it returns the index of the element that we're looking for. Yeah, that's the one. Elem index. Yep, that's what we do. I wonder if that is just part of it, or if we need to import. Actually, let's check that. GHCI, and we check LM index 1 and 1, 2, 3. Yeah, it's not there. We have to import data.list. Kinda like LM, yep. Do we only need LM? Import data.list. LM index 1. Oh shit. This needs to be guards anyway, so right, so we have one guard for that, and we have another guard for, look at this. Copy and one for 0. No, wait. We don't need to do that. No. Do something like that. Colgatinotab says, I'm curious how to see how smart people have solved this. Why, thank you. Yeah, I'm curious about that as well. I'm gonna be pissed if there's a math solution. Yeah, I'm gonna be pissed if there's a math solution. I don't want to do maths. Wait, no, this doesn't work. We can't do guards like this. No, guards has to return Boolean, order lists, right? Ordering stuff. So we could only use lm. If we do lm0 in this list, what we do is that we take... Shit. I kind of want to take the two lowest values, right? Oh, I can't do that, right? Since they are ordered. We can sort the list. That's what we do. We always sort this list because we know that the first value is the smallest one. And the second value is the second smallest one. And if our list is sorted, and if we know if 0 or 1 is in the list, then we plus the two first values and we multiply with the third. That's how we do. So we sort the list. Shit, I don't remember. What was the name of that? Was it just called sort? Try that. Sort. And that's in data.list, I'm pretty sure. Colgatinotab says, remember that A and C are symmetric, but B isn't. Metric? I don't understand. Metric? Now you're thinking with portals, says NodeRunner, right? Yeah. Import data.list. Double check here. Sort 1, 2, 3. Exactly. What we do is that can we make like an OR statement, right? Like lm0 or lm1. Can I do those? Because I want to do the same thing in both of these. There is something like that, right? If I do it like... that. How do you do that again? Where's that? Looking for it. Like something like that. No, that's not how you do it. Colgatinotab says expression ABC is equal to expression CBA, but not necessarily to expression ABC. Wait. It's not... Expression ABC is definitely equal to expression CBA, but not necessarily that expression ABC is equal to expression BC. Wait, but ABC is the integers that we're getting, right? We're given 3 integers, that is ABC. So expressions ABC, just A is one of our integers, B is another one, and C is the third integer. So it doesn't matter, right? I want to have a list of these integers that I sort. No? Yes? I'm confused. Right. But this has to be the list, right? A, B, C, and the same here, lm1 is a list of A, B. Gotta be a better way to do that. Maybe I misunderstood. I thought the order was locked. Oh, right. These are just 3 integers. I am creating a list of the integers, right? Do I probably do a little bit like this so you can see what's going on? But that, all right, let's try this. Does this work? Do lm0 abc, right? That returns false, which we wanted to, right? Then we take and no, we need or. We need that lm1 this 1 2 3. That returns true, right? We don't need and, we need or. And we need or. And if we do that, we return A plus B multiplied with C. And a parentheses with this. A plus B, oops, multiplied with C. Right. And otherwise, we will return A multiplied by B multiplied by C. That's how we do it. So we take all of this junk away. We take this away. Boom. And that. Oop. No, we need to... Shit. We need to sort the list. I haven't sorted the list. Well, I haven't sorted the numbers. Right, we make another function for that. I think is easier. Right, we take sort A, B, C, right? We take all of those, which is a sorted, which returns a sorted list of A, B, C. Actually, yeah. Because in here then, what we can take instead of A, B, C is that we take X, Y, Z. Right, because we're having a list. And we're taking... We can just remove these, right? No, we're having a parentheses. So we have to... It actually... Fuck, I don't know how to undo in this editor, so we just do... X, Y, Z... Shit. Right, and here we go. I don't know why I changed these around. Why did I do that? Who knows? Right, so we have this sorted list, and on that sorted list we will call a function that is called calc. Yep. Calc on the sorted list. So this one is going to be called expressions. This one is going to be called calc. That work? Right. Maybe it's easier if you implement and utilize Frank in your solution. Oh man, that sounds awful. All right, let's test. Right, what error did we get? Curse check cannot construct the infinite type of in the expressions E. Wait, what do we get in here? Infinite type? Second argument of LM, namely. Is it this shit? I thought I tried this, right? It returns true. Is it this? That it somehow... Do we... I mean... Right. We don't do a list. Can we sort a tuple? And it would be better to have, well, a triple, I guess. That can be a list. Yeah, exactly. I was thinking that was why I was thinking of having a tuple instead of a list, because, well, there's only 3. We're only gonna have 3 values, right? Oh. Wait, does that work? Can I just do it like this? No. No. We're already sorting it, right? Let's try that. No, I don't think that'll work. Will it? Yeah, no. Right, we're having a list. Do we... Oh, sorry. But can we do this? Wait, not instead like this. I don't understand why that would work. Well, we did get another variable not in scope. Expression. Ah. Somehow worked, but we got the wrong answer in one of our tests. Expected 3, but got 2. Shit. Alright, so what we do is that we then Since I don't know what kind of thinking we did wrong. Oops. What we do, since we did get something wrong, is we have to do a little bit of science, which means that we open up CD stuff, learn Haskell, stuff, learn Haskell, right? And we do, what's it called, this thing? Expressions matter. Alright, so vim expressions.hs 111. Oh! Shit. That's the one, isn't it? Yeah. We expect 3 when we get 111, but we got 2. We didn't think about that use case. Shit. Right. How do we deal with that situation? There's probably a count, right? That we can count the number of times the elements show up. Right. Let's check that out. Right. Count number of times element in list Haskell. There's got to be a function for that. Something like this line. Counting how many times each distinct element in a list. Exactly what we want to do. Data.map frequency. Wait. To list from list with. Oh, wow, that was not implemented straight off the bat, was it? I don't remember seeing this. Wait, why do we need from list with and to list? Actually, let's read the question so they're actually looking for the same thing that we're looking for. Oh, Colgate tab says I usually do length LM indices. Right. Where are we? Yeah, we can get... That's what I was doing before, right? We get LM in the indexes. Is that how it's spelled? Wait. Nope. In my indexes, right? Take LM and spelling is awful, isn't it? Right. Eleming this is right. We got a list here. We got a list here. We need to join these two, right? And it feels like we should do an extra function for doing this. Yeah, we should do an extra function for this. All right. We call this index this because that's how it should be spelled, right? Which will return. It will return this whole thing. That work? No, that only matters for one, doesn't it? And if we get 0, 0, 0, it doesn't matter. If we got 0, 0, 1, it does matter. Yeah, 0, 0, 1. So the length of these yeah, this cannot be longer than 2, right? Spoiler, you don't get 0. But we don't know that. Right, with the tests? Yeah, I mean, we don't know that. We'll assume, right? But what we do, this length, right? If it's greater than 2. Yeah. So if... Oh. Don't, but I read the instructions. Wait. Notes, the numbers are always positive. The numbers are in the range 1 to... Oh, wow. It said so, yeah. It said so in the instructions. I completely missed that. Use the same operator more than once. It's not necessary to place all the signs and brackets. Repetitions in numbers may occur. You cannot swap the operands for given. Okay. So, thanks, Colgate in on tap. Yeah. I'm terrible at reading instructions, aren't I? Alright, that makes life easier. Then we don't really need to do the function because we can, like... Sure, it's a mess, but it's not the worst kind of mess because we take this... Right, we just take that and we take... where is it? Length. I think we can do this, right? We take 2 is... Wait. Yeah, this has to be longer than the length of this list. There we go. Also, it seems I was correct about not swapping the order. Cannot swap the operands. For instance, the given example, you cannot get the expression... Oh. Wait, I'm confused. You cannot swap the operands? Give an example, you cannot get the expression 1 plus... Oh, yeah. Wait. So I can't do... And in this, I couldn't do 1 plus 3 in parentheses multiplied by 2. That means our thing won't work. Cannot swap the operands. That means that X, Y, Z, we cannot switch those. We can't have X plus Z in parentheses multiplied by Y. We're not allowed to do that. That means my whole approach won't work. Why not? Oh, fuck you. Fuck you. It works for most inputs? Yeah, it works for most of the stuff, but it doesn't work for the task at hand. Right? My approach was based on this, right? Everything I did was based that we were able to sort this. But we're not allowed to sort. Right? That's how I got rid of that whole... doing it for all those versions. Right, because I wanted to take the... Yeah, I wanted to plus the 2 smallest values together, but that's not it then, right? What we do then is go by index, and we just take index and multiply with something, right? Right, what we do instead is just that we have to rethink this whole thing. You can just pattern match for what it doesn't work out. I suppose we could pattern match, like, feels like a cop-out, but I guess we could. I kind of want to redo it though. Yeah, because now I'm thinking, right? Since we cannot change the order of the numbers, and we don't get the number 0, which I missed out on, right? Which means that we can instead do a list, and we can just loop over the list if I don't know if we do it with a fold or whatever, right? No, we do it with a recursion, right? We go from the number. If the number is 1, then we plus it. And if the number is... No, if we get the number 1, we plus with the next number. And all other cases, we multiply with the next number, right? That's what we do. Yeah. Yeah. If the head is equal to 1, then we plus with the head of the rest of the list. That work? No, shit. It's either or, right? Because that won't work if the last digit is 1. Damn it, it doesn't matter. If we have the number 1, we have to plus with either to the right or the left. We just need to plus. No, we have to plus with the lowest of the 2 numbers if it's in the middle. Maybe I should just go like. Maybe I should just guard this whole out. Since we don't get the number, we only have 3 different. Yeah, let's cut all this out and just do it the way I was thinking originally. Right. Actually, before we cut that out, we'll just try again. And expressions ABC. Right. And then we just say guard. No, actually we pattern match. Wait, does this work? ABC is equal to 1 plus B. No, fuck, it doesn't work because I have to check which is... Oh. I mean, that one works. This one becomes a problem. Well, not the greatest problem, I guess. Because what we do is that we... Here we make a guard. Right, if A is smaller than C, then we return A plus 1 multiplied by C, otherwise we return A multiplied by 1 plus shit. But I still run into the same problem with the triple ones, but we can just pattern match that as well. All right. And we expression AB1 is equal to A multiplied by plus 1. Right, and we do expression 1, 1, 1 is equal to... Right, and that's all our cases. That's way easier. I mean, there's a lot of coding going on where we fix it for each thing that we did. That should be working, right? And we don't need to bring in data.list. We don't have to create any lists. We don't have to do any fancy coding. We can just pattern match all of it. No? Wait, what did I do wrong? Non-exhaustive pattern in the function expression. Oh shit. Wait, was that the problem? No. We need a catch-all, is that what they're saying? Pattern match fails, source expression, non-exhaustive patterns in the function expression. Alright, so we need a pattern match. Alright, so what? Expression for all of the rest. Actually, we don't even have to do that. We just do expression error. I missed something. Different numbers of arguments. 1, 2, 3. Equations for expression have a different number of arguments. Is it because I did this instead of this? That it needs 3 arguments? Error call, I missed something? I did miss something. What did we miss? Right, we got the 1, 1, 1. We got this one. Got that one, and we got this one. And all the other iterations. Oh, ABC. Shit. I missed the important one. Yeah, I missed the important one. So, yeah. We don't need... This one is just... Oh, man. The one that's gonna happen all the time. That's the one. You want spoiler? Never mind, you got it. I just missed the important one. Yeah. The one that does all the stuff. These are the edge cases, right? Easy to miss, but there we go. How did other people do it? The best thing? Wait. Right, someone did it. Expression, they took the maximum from expression 1, 2, 3, 4, 5, 6. I'm assuming I had 6 as well, right? 1, 2, 3, 4, 5. Yeah, 6. I don't know. I kind of liked my better than this. This felt like... Why is this better? It feels not as readable. Actually, no, we're taking the maximum and then we have all the different expressions. They tried all the different iterations. Yeah, since all the different iterations weren't... Actually, yeah, this one is more codey, right? It does it the way that it follows the instructions to a T. It actually does all the calculations. My solution was hackier, while this one is actually doing what was asked of us. So yeah, maybe. Oh, this one is mine. Yeah. How does this got... Oh, someone else did this? Oh, shit. Oh, sorry. Oh, that was mine. I was confused. Well, this one does... Oh yeah, this one did it exactly the same way. It just put it all in this list. Yeah, if I would have read the instructions from the beginning, then I might have, right? Because there are not that many iterations of ways of doing it, right? A plus B plus C times B times... Yeah, I mean, this one was the best, wasn't it? And it dropped expression 4 as redundant. Yeah. Yeah, this one did it as well. Yeah, it dropped the redundant ones. Yeah, this was the same as this one. Yeah. Those two were the same. Dropping the redundant ones, that's definitely better. I like Alamar solution, this one. Yeah, this one was very readable, wasn't it? I liked how they put them like in this order and everything. Yeah, I thought this one was probably my favorite. Is it because of the spaces? Yeah, it's the spaces on the ordering of the stuff you did in here. It was most readable? Alright. I gotta start voting. Feel like that, yeah, because this one is beautiful. Mine is just awful, isn't it? Alright. But I think that's it for today. I kind of like this one, right? It didn't... Yeah, I'm happy when we're doing coding and not maths, right? Because even though there is a lot of maths going on in here, this is maths I understand, yeah. Well, Untitled Chapter says participate in democracy, right? Yeah. This kind of thing is all built around that. Crowdsourcing stuff, I like that. But I think, yeah, that's it for today. Have I gotten a message for today? No. Weird. Lunchtime an hour ago. And alright, next time we will continue with finally... Oh, lost track of that. We're finally gonna do Hello World. Finally doing Hello World. Looking forward. Knowing that those two expressions are unnecessary is a bit math. You could say, right? You could say it's Haskell, right? Since those two unnecessary things, they were the same, right? Just did the same thing. It was just recognizing that, oh, this is the same as this. Just a little bit math, but, right? I feel like a little bit of math is... You cannot get rid of that, right? When you're looping over lists and whatnot in programming. I don't know. But okay, that is it for today. So thanks for hanging out. And yeah, have a good one. Cheers.